Metallic bond. Metallic bond is formed from electrostatic attraction between the positively charged metal ions and the sea of delocalized valence electron. If it's from positively charged and negatively charged, that is ionic bond. Now it's metallic bond. Metallic bond, positively charged metal ions, the metal is positively charged, and the sea of delocalized valence electron. I'm going to show you on the next slide what sea of delocalized valence electrons look like. And take note that metallic bond is intramolecular force. It's intra, not inter. This is intramolecular force. Metals also have very high melting and boiling point because they have strong metallic bonding. Electron C model. This is the Electron C model. This Electron C model is for group 1 metal because you can see only one electron is released for each atom. So this is for group 1 Electron C model. All metal atoms contribute their valence electrons to form an electron C that is delocalized over the entire solid. Delocalized means it's not fixed at one place, so it keeps being around here. It's not at fixed position. Positively charged ion, so this is the positively charged ion, the nucleus, positive charged ion, nuclei, and inner energy level electrons. This electron is just the valence electron. Since one valence electron for each atom means this is Electron C model for group 1 metal. Metallic bond formed from electrostatic attraction between positively charged metal ions, nuclei. So this is positively charged metal ion, and the sea of delocalized valence electron means this positively charged metal ion attract the valence electron of the sea of delocalized means it's not necessarily to attract its own electron, it can also attract to the valence electron of other atoms as well. So that's what we mean by sea of delocalized valence electron. So the sea of valence electron is acting as glue bonding because the position of the valence electron here, it's moving, it's not fixed at one particular position only. The positive ion which would otherwise repel each other. So when this electron meet this electron, they will repel, and if this electron meet the positively charged, it's like glue bonding, so it will attract. This is Electron C model. This Electron C model form the metallic bond. Properties of metal: lustrous, bend or dent, malleable, flattened into sheet. Malleable is different from ductile. Ductile you can pull into wires, but malleable flattened into sheet. Conduct heat and electricity. So these 5 are the properties of metals. Why most are solids with moderate melting point and much higher boiling point? So this statement is for metal. Most metal solid moderate melting point, but the boiling point is much higher. It means is you only need moderate energy to melt that metal, but you need very high energy or a lot of great energy to boil that metal. Melting point is moderate because the attraction between movable cation, the nucleus positively charged, and mobile electron, this C delocalized electron, that is mobile electron because the electrons are moving, need not be broken during melting because you just melt it, you don't need them to be broken. So that's why melting point is just moderate. But to boil it, boiling point is higher because it requires each cation and the mobile electron to break away from each other. You need to break them from each other. For them to melt, you don't need to break them, so that's why only moderate heating. But boiling, you need them to break away, so it requires much more energy for boiling. Why metals are malleable and ductile? Metal atoms form metallic bonds to many neighbors. So we know that the metallic bond is different from ionic bond. Ionic bond, transfer of electron and receive electron, and you form bond fixed. But metallic bond, the electron, valence electron in the sea of delocalized electron, it's moving. When a piece of metal deforms a hammer, the metal ions slide past each other through the electron C to new position. So it can form new shape, new position, because this nuclei, this row, this second row, third row, and fourth row, it can still attract to other valence electron within the Electron C model. So you can reshape the metal. Changes in position of metal ions brought about reshaping the metal accommodated by redistribution of valence electron. For example, initially there are few electron moving here, and then you put the external force here, and then making this positively charged metal ion move a bit to the right, and some of the electron here change the position and stick to other nuclei. So that's why it can cause redistribution of valence electron, cause the reshaping of the metal. You cannot do this in ionic bond. Ionic bond, it'll just break out. It cannot be malleable or ductile. You cannot reshape the ionic bond, only for metallic bond. Why metals conduct heat and electricity? First, because metal atoms have mobile electron. When there is the existence of mobile electron, you can conduct heat and electricity. If the electron is fixed, the position of electron is fixed, that it's not mobile, you cannot conduct electricity. Why mobile electron can conduct electricity? The conductors are made up of atoms within which some atom will have the tendency to give up electron, higher potential, and some atom will have the tendency to accept electron. So this is the description for conductors. Conductors, usually some of the atoms prefer to transfer electron, some of the atoms prefer to accept the electron. So when there is the different properties of the atom, some atom want to accept, some atom want to transfer. So the difference between the amount of atom state is higher potential, give up electron, lower potential, accept electron. So the difference between this higher and lower potential cause the voltage, cause the potential difference. Potential difference is a voltage. So once this potential difference is created, the electrons are forced to jump from one atom to another atom. During this transition, there will be a certain amount of energy emitted. So we know that when electron move, jump from one atom to another atom. So there is a transition of electron. When there is a transition of electron, certain amount of energy emitted. Like we learned previously here, this one. What caused the movement of electron? Because in the conductor, some atom give up electron, some atom accept electron. When there is difference in potential, we call it potential difference, that's voltage. So that's why metal can conduct heat and electricity, because there is existence of mobile electron. Strength of metallic bond depends on the number of valence electron and the size of the atoms. When you have more valence electron, means you have more delocalized electron. For example, here you have sodium atom, group 1, aluminium atom group 13. So group 13, 3 valence electron, sodium group 1, 1 valence electron. The attraction between positive ions, this Al3+, a positively charged nuclei, Al3+, and the localized electron is stronger in aluminium compared to sodium. Because in aluminium, you have more positively charged and more electron per atom, more valence electron per atom. 3 valence electron per Al atom. This one, 1 valence electron only per Na atom. So when you have more delocalized electron, stronger delocalized electron, stronger metallic bond. Size of atoms, the smaller the size of the atom across a period, we know that across a period the size will be smaller because effective nuclear charge increase. The attraction between positive ions and delocalized electron stronger because across a period from left to right, the positively charged nucleus, the proton number keep increasing. So that make the delocalized electron stronger metallic bond. So that's why smaller size has stronger metallic bond, because smaller the size means you have more and more proton number across a period. That's for metallic bond. Thank you.